Good afternoon, everybody. Welcome back to lecture number 2. Today we will start our business, okay? And please, please try to come on time, okay? So today we will start introducing electrical engineering to you, okay? So please pay attention. Better for you to understand why you're doing this, so that when it gets a little bit challenging, you have enough motivation, okay? So first of all, what are the objectives of electrical systems? There are two things electrical systems exist, otherwise there is no point of it, okay? Otherwise there is no point of having electrical systems. The first part is we use electrical system to process information. This usually translates into a very low voltage, 5 volts, 2.4 volts, computers, smartphones. So anything that has to do with information, small chips, calculators, cameras, we deal with information. The information can be image, can be sound, can be numbers, can be any other thing. Ya shabab, please don't come late anytime, okay? The second aspect of energy systems, we use them to do what? To transfer electric energy. This has to do with my major power systems, okay? Mainly mechanical engineers. Who's the mechanical engineer here? If you're a mechanical engineer, you will be dealing with generators. You will be dealing with fossil fuel plants where we burn fuel, we burn coal, we burn gas. So we can convert this energy, store it, and distribute it. This usually high voltage levels, 10,000 volts. The electricity you get here, 220, it's not here, it's the other way, 220 volts. So we deal with it to transfer energy. Why we transfer energy? To get some work done. It could be light, it could be mechanical movement, it could be any other aspect. So there are different majors. If you have friends in electrical engineering, feel free to ask them what level 4 courses you want to take. Some students take level 4 in power systems. Some take level 4 in communication. Some take it in computer engineering or embedded systems. Some take in control systems. Who's the mechanical engineer here? You're going to take control system course, and this is a prerequisite. You know this course, correct? Electromagnetism, كهرومغناطيسية. We use electromagnetism for radio, for radars, for military, etc. Electronics, we use electronics to build calculators, computers, sensors. Photonics, the applications that have to do with LED applications, TV, etc. Or signal processing. One major aspect of signal processing is machine learning application. Anybody knows, if you want to summarize machine learning, where is it?
It's to train a machine with the data and then test it.
In a simpler term, who took Math 201? You remember this logo?
Yes.
What is this? Gradient. Gradient is a vector that you apply it across different functions, and depending on your gradient, when you train the data would move guided by the gradient. So in signal processing, they teach electrical engineering students how to process this data in a more mathematical oriented way compared to computer science. Computer science would focus more on the algorithm, the computational capacity. For electrical systems, we care about mathematical modeling, the signal processing itself. So in a nutshell, this is electrical engineering. But why we take this course? We are non-EE. First of all, when you graduate, you have to pass this exam to be a professional engineer. Fundamentals FE. FE may have some questions about electric circuits. So you have to do it in order for you to be fundamental engineering certified as well as professional engineer, to get the professional engineer certificate. Assalamu alaikum. Please don't come late. What's your name?
حسين
Last name?
شرف الدين.
Late. 5 minutes, we start counting days. So we need to pass the FE exam, correct? Then we want to have enough knowledge so we can work with electrical engineers. We don't want them to trick us. If you're a mechanical engineer and there is an electrical engineer working with you, you want to have some knowledge in order for you to work with them in the big projects. For example, if you're building the stadium, there will be electrical engineers. Excuse me, what's your name? Rod. Late. To be able to operate electrical systems, if you work with a company that's its primary business is electrical systems, you have to take this course. As well as just to communicate with other engineers. What if you become a manager and you have electrical engineers working under you? That's very important, okay? So 4 motivations, you need to know them in order for you to understand, in order for you to answer the question, why am I taking this course? Clear? Okay, let's start with physics. And I want you to watch this video at home. For some reason, I cannot operate, or I cannot play videos in the classroom, otherwise the video will be somehow triggered. So, when you watch this, we are familiar with the electric charge, correct? And it has a logo E, and it has a negative charge, correct?
Yes.
And the electrons move from what? From the negative surface to positive surface in the direction from right to left. In a nutshell, electrical engineers were way ahead when they discovered that electrons move this path. And electrical engineers, they said, okay, let's define electric current to flow. The electrons, they would flow the electric current I, or capital I, it doesn't matter for now, that move from positive voltage to negative voltage. For some reason they thought before, Tesla, long time ago, they thought that the electrons move from positive to negative for some reason. They didn't know that the actual charge is negative, 1.6 times 10 to minus what, 19?
Yes.
Coulomb. What's the unit of charge? Coulomb. So they built all of their science under the assumption that the electrons move in the direction of electric current. So the direction of electric current is actually the movement of holes. Are you familiar with holes in physics?
What?
Holes, الثقوب,
Yes.
in physics. So the electric current is the flow of holes, not electrons. That's why if you have a battery, and this is the symbol of battery, we usually have the electric current going from the positive terminal. Think of it this way. Electrical engineers were ahead of physicists. They thought that the direction of electrons is from positive to negative, but later when the physicists discovered that the actual charge of electron is negative, they said, no, we're not going to change it. Okay? That's why if you have a battery, it is more convenient to keep the direction of the current away from positive. Clear?
Yes.
Please don't confuse yourself, okay? Electrons move from negative to positive, that's physics 102. We're not doing physics, we're doing electrical engineering. We want to be engineers, we're engineers, we're not scientists. Let's continue. So how electricity works is simply the movement of electrons. That's it. They move from higher potential to lower potential. Talking about holes. So whenever you see electric current, it's not the electrons, it's the holes. Okay? Now, Electrons move. Let's say we have this setup of battery. You did this in school, correct? Maybe elementary school. Right now they do it in elementary schools. There is a switch, there is a resistor, there is a lamp, there is a battery. So the black cable is the positive, so the holes or the electric current would move here. Okay? For some reason they connected it to this negative, positive, it doesn't matter. It goes here, and then it goes from this cable to the resistor, then it goes back to the switch. Well, I think this is a fake circuit. No, it goes here. Like that, it goes here. معلش أعيدها لكم. البوزيتيف الأسود هنا. It goes from here to the switch. It goes back from the switch to the resistance. Then it goes to the lamp. Every LED مع resistor they are in the same column معناتها إنها نفس السيركت. Okay? So it goes here, يطلع من هنا, and then it goes to the red, and then the circuit is closed. So where is the direction of the current? The direction of the current is actually, well, here it shows this is the positive, depending on the polarity, okay? Doesn't matter how the cable, but the point here is electrons move from positive to negative. Electric current move from positive to negative. Electrons from negative to positive. Okay, depending on how this is wired. الأسود على الpositive or negative, it depends, okay? But this is how a closed circuit works. And then if you turn off the switch, you open the circuit so the light will not operate. Any question about the circuit? Clear? So when you do the lab, you will be dealing with similar stuff. That's how you can see. Now, if you have an electric car, every car has a battery, correct? And it has auxiliary system that powers the lamp, the TV monitor, the monitor of the car. Any electronic system is connected with the battery. So, what is the voltage level of car battery? 12 volts. And if your car has 10 volts, then you cannot turn on the engine because lower voltage will not be able to what? To operate the car. Okay? For some reason, dealing with these circuit or the previous circuit somehow involves complexity. The cables are routed this way to the left, and then there is curves. But it might be difficult to analyze. What electrical engineers are doing is they say, no, we will have electric circuit. So let's draw electric circuit. Let's draw electric circuit. To draw electric circuit in EE236, you have to understand the components first. How do we draw electric circuit? So what is this circuit? How many elements? 1, 2, 3, 4. How many elements?
4 elements.
4 elements. We have first the battery. Then we have a breaker, which is a switch. Then we have 2 resistors that are in parallel. In parallel means they are sharing 2 nodes. This is one node. This is another node. So we have resistor 1, let's call it R1. Resistor 2, let's call it R2. And for some reason, one is corresponding to resistance, representing headlamps. We represent the headlamps by the symbol resistor. And conductors, they are wires. So this is the headlamp 1, this is the headlamp 2. Okay? Then this is if you close this breaker, what will happen? If you close this breaker, electric current will move from here. So we call this I of usually sub S. ايش معنى sub S? Source. So I sub S means source current. تيار اللي يطلع من السورس. What is our source? It's a battery. Now, do not confuse yourself. If no electric current logos are present in your circuit, you have to put it in your own. Think about it as a water. So this water goes here. Once we close this switch, it splits into IR1, IR2. Does it make sense that we put the current go from here and then it splits into two branches? Yes, it makes sense. If another student, for example you, yeah, what's your name? If Abdurrahman said, no, I want my currents to go from here to here, then what should we tell Abdurrahman? You're right or wrong? No, he's still right.
Yes. Change this up.
Because it doesn't matter. I define the current. If I'm moving from here to here at a speed of 5 meters per second, it means my speed from here to here is minus 5 meters per second. So it doesn't matter in the exam, you can put the polarity from top to bottom, he can put it from bottom to top. Nobody cares. As long as we maintain our professional notation. Professional notation means you put the equations properly. Okay? So this is a basic electric circuit. And usually, yes please.
Doctor, as you explained, from your explanation, I can understand that if we change the switch, if we move it to the opposite side, will it operate the same way?
Had a switch.
Yeah.
If you open the switch,
If we move it to the other side,
if you move it to the bottom,
yes, will it work the same?
it will work the same. Because the current that goes here goes to the battery, it's the same current that goes here. However, the current in every lamp is different. Okay? And before you analyze every system, ask yourself, how many bad electric elements do I have? How many bad electric elements? 1, 2, 3, 4. What else? The conductors or the cables. So, in a nutshell, there is wires, and wires are made of copper, اللي هو النحاس. Some wires are made of aluminum, but most of the wires are made of copper. And every wire in the lab, it is insulated with material, so that when you put your hand, it doesn't electrode you, okay? That is very important to understand. And why copper is expensive. So in electric facilities, they put fences around the electric facility so that people do not steal the copper. Okay? What else we have? Switch. Switch in mechanical engineering is like a valve. If you open the switch, there is no electric current, so the lamps are off. If you close it, it's basically a contact. It's made of steel. If you click on it, there is a spring that would close it. Okay? It's very simple. And then we have the loads, which are usually resistors. For now, the only loads we're going to deal with, resistors for major 1. Okay, major 2, to have something else. So, if you are a mechanical engineer, you do these things. I really don't know how to do these things. What is R in mechanical engineering? Do you know? Do you call it resistance?
Resilience, maybe.
I don't know. Mechanical engineers, you have to teach us.
Charge constant.
Yeah, what is R? Is it the radius of the pipeline? I don't know.
Must be resistance.
Do you have a quantity called resistance? In electrical, R means resistance. So let's look at this system. Are those two resistors in series or parallel?
Series.
Why series? Because they carry the same water, the same electricity. The key about series is they carry the same current. The key about parallel is they have the same voltage, or they share two nodes. So what is the system? We have a battery 12 volt, we have resistor 1, resistor 2. In mechanical engineering, we have high pressure, low pressure, that's a pump. And the pump would push the water, and then there is a narrow path, what will happen?
High pressure.
High pressure here, and then it becomes less, and then it goes back to high pressure, and then it goes back. So resistance is basically a measure اللي هو معاوضة أو مقاومة. Is a measure of how this lamp would resist the flow of electrons. And what is the result of this resistance? We have a pressure here or a voltage drop here that's somehow measured proportionally with the resistance. We'll talk about that later. So think of a resistance as how wide your pipeline versus how small your pipeline. So if I have a very high resistance, it means I have a very narrow pipeline. High resistance, very narrow pipeline. But in electric circuits, it's not only a function of the actual diameter of the component. It's a function of the chemical part, etc. But what did I tell you last time? Think of the voltage as pressure. Think of current as water flow. Clear? So if I'm measuring the pressure, I need 2 points. If I'm measuring the flow, I measure it through the element. We measure the current through the element. And what's the unit of voltage? Volts. نسبة للعالم اسمها volt. And what's the unit of current? Ampere. نسبة للعالم اسمها ampere. Okay? In electric circuits, we do have other elements, such as capacitor or inductor. You did study them in physics. Capacitors and inductors, they store energy. They store energy, and we will talk about them in major 2. Okay? This is how inductor looks like. This is a resistor, this is another inductor, this is a capacitor, and this is what? A capacitor that has a unit of 1000 microfarad. Okay? And what's the unit of inductance? Henry. What's the unit of resistance? Ohm. Resistance Henry, capacitors measured in usually microfarad. Okay? Now, electric circuit consists of those elements. Once we connect them, we close a path. How many closed paths do we have here? Let's look at them. This is the first closed path. 1. This is the second closed path. 2. This is the third closed path. How many? 3. So a closed path, it means if I connect this circuit, electric current would go here, split here and there, and then they will come back to the negative terminal of my source. And this is what we mean by a closed path. Voltage sources create forces that cause a charge to flow through the conductors and other circuit elements. Think of it as this is a pump of water. It pushes the water through the resistors, through the capacitor, and through the inductor. And then the pump, should it have a return path? Yes. Can you have a pump with only one terminal? No. Same for voltage supply. Cannot have. How can you return the fluid? Okay? So we have ME, we have industrial. Where is the industrial? I told you to sit next to each other, please. This is the side of industrial, please. It's better. Okay? So you group together. ME, material science, aerospace. It's up to you. I cannot mandate. I cannot impose it on you. But that would be good when I give examples. Okay? So next time, please, the industrial, try to stay here. And we have material. I think 1 or 2. 1 material. No aerospace. We have 2 aerospace. What else? Any other majors?
Computer engineering.
Computer engineering. Yeah, you're electric. See. Computer are like my team. Okay. So, what did I tell you about this? Do you remember now the electric current is the direction of the holes? Why? Because electrical engineers were ahead of time. And what is the electric current? By definition is rate of change of charges across the time. It's dq dt. So electric current is like the flow. Flow is rate of change of water across time. Electric current is rate of change of charges as a function of time. By the way, for those who came late, we have a leave whenever you want policy, okay? If you want to go bathroom, coffee, feel free to go. Within reasonable limits. So the unit is what? Amps, which is also column per second. Column per second, we do not use it. It's not used in electrical engineering. Most people, they use amps, okay? So what is one column? Minus 1.6 e to minus 19. Let's do a quick exercise. A constant current of 2 amp flows through a circuit element. In 10 seconds, how much charge passes? So current is rate of change across time. So if I want to calculate the charge, I need to integrate. Okay, but this is a constant current. So if I have in 1 second, so 2 amps means 2 column in 1 second. So 10 seconds, how many columns? 20. We just multiply. That's how to solve this example. 2 current times time, which is a 20 column. Again, this might be in the major exam, maybe the first question, just to warm up before the exam. But if I have in this example, I am having the current written as a time expression of 0.01, the amplitude, times sine 200t. Now it's time to do math 101. So I is what? dq dt, correct?
Yes.
So what is the derivative of q with respect to time? Chain rule. 0.01
times time.
times, the math is hard, we multiply by derivative of t, chain rule. What's the derivative of sine?
Cosine.
Cosine. 200t. What's the unit? Now if you don't do unit, please put the unit with brackets like this. It's more proficient. Okay? If you put them under brackets, it's more proficient. If you forget the unit in the exam, Yami, what will happen?
Zero.
Not zero. Usually minus half. Minus half. You lose half of the point just because you forgot the unit. Clear how to do the derivative? Maybe in the exam, a trick question, we ask you to integrate. We give you this as q. No, we give you I, and then ask you to find the q. You do integration. Can you do integration by parts? Can you do integration by parts?
Slightly.
So I will try to ask the exam instructors, all the other professors about this idea. We give you integration by parts. Integration by parts. U dv and then forgot uv minus du. We did integration by parts in high school. Do you remember?
High school.
No.
أنا ما سمعت فيها إلا يوم صرت صفر.
Freshman. ولا أنت ما أدري. So integration by parts is probably my favorite. Integration by parts is easy. It's hard. So try to at least do some problems in the book. Try to do these exercises, okay? Please. What else we have? Now this is another example where he's taking the derivative. What's the derivative of this expression? 0 minus plus 100, 200, to be 200e minus 100t. It's easy. So that's one trick. Okay? Now note that this is a piecewise defined function at time 0. But in engineering, do we care about time before 0?
No.
No, because it's something from the past. So how to sketch it? Well, you can use any plotting tool, but basically, one way to do how to do it is put t equal big number. So this would vanish. So it would converge all the way to 2. And then if t is 0, this is 2, 2 minus 2 is 0, and then you can plot. That's one quick way to plot it by hand. If you don't know how to plot a function, Pick the two extreme and pick two numbers in the middle and just do whatever. That's one way to save 5 minutes in the exam. But if I want to plot this, this is a typical exponential. 0, this is 200, so it begins from 200 all the way until 0. DC versus AC. You did that in high school. DC means electric current and voltage is a constant real number. It means across the time, for example, the AA battery, what's the DC voltage? It's 1.5 volts. No matter how the time goes. AC is alternating current. If it was me, I would call it direct current, sinusoidal current. So alternating current means most of the time sinusoidal. So either we have it as constant or we have it as sinusoidal with periodic sinusoidal. So DC currents are constant with respect to time, while AC currents are what? Vary with time. Most of the electric supplies are sinusoidal. However, there are some applications, for example, motor control, where you get, for example, shapes like the saw, minshar, or you can get pulses, digital. So those are also AC. But the one you get from the wall is AC sinusoidal with 60 hertz. In 1 second, you will have 60 of those sinusoidals. It means each one of those sinusoidal has a time of 16.6 milliseconds, each cycle of those sinusoidal. And this is how it looks like. And look how they plot T as a function of time. So 2 volt doesn't change. But sinusoidal, it changes across the time. Okay? Let me do some technical check because I want to stop the video at 40. And then we record another video. And after 1 hour, it will do all the show. The lecture is longer than 1 hour. So remind me at 40. Plus or minus.
10 minutes
Around. So this is what you get from the wall. Is this UK or United States or Europe?
UK.
This is UK. Now the one we have in KFUPM here, we have two. One is American. This is US. This is UK. Okay? They vary in shape for safety, etc. And the European ones are circuits. Okay? There is also other shapes, but try to have a universal adapter, okay? What else we have? Notations for current. So, unless otherwise specified, if I have a resistor R, we usually, in electrical engineering, we either call this current I1, maybe branch 1, or maybe we call it I sub R1, or we may call it, if we have this point A, point B, we may call this I of A to B. Whatever. I can call it I, what's your name?
Rakan.
I Rakan. Doesn't matter. But usually, if you see I sub 1, it means the first current, or the current of the first branch, or I R1. I find this is more easy when you write your circuit. I R1, the current of the first resistor. But here what they want to tell you is, what about this current? If I call this, if I want to write this current as a function of this current, what should I do? minus I1. How about this? Minus IR1. How about that? IBA, which is minus I of AB. And that's basically what they say. How about IRACAN? Minus. Okay? So in electrical engineering, if you use a subscript of two nodes, if you reverse it,
عندي سؤال.
تفضل.
ليه هنا بالسلايد غير الإشارة والأحرف بعد عكس ما أماكنها؟
This is A, this is B.
إيه بس صارت ماينس
So IAB is minus of that current.
ماينس بي إيه.
That doesn't matter. This is notation. Yeah, I got your point. We rarely have current with subscript of. فهمت عليك. I got your point. Yeah, this is IBA. I from B to A.
إيه بس غير الإشارة حتساعد ولا ما يحتاج؟
If you put sign, then they are equal. It means if I put minus, I flip the
ما
direction.
كان له داعي إنه يحط بي عادل.
لا له داعي. كيف ما له داعي؟ This is I from B to A is actually minus the I from A to B. And this is the equality. واضح؟ Basically, if you add them, if you put this here, if you add them, it's 0. Clear? Capital or small, it depends on your node. Sometimes we find capital nodes, sometimes small nodes. But what's my favorite? IR1 or I1, depending on the circuit. For voltage, we have, in physics, you remember this, sometimes electrons, positive and negative together. After some time, they uniform what we call an electric field. This is physics. So the voltage is basically the work or energy that must be done to separate those positive from the negative across a certain element, or the energy it takes to pull one of those electrons away. They push each other. This is the physics meaning. But what's the electrical engineering meaning is the capability of that energy source to provide electric current for a certain load. It's capability, قدرة. So voltage is the energy per unit charge created by the separation, energy transferred per unit of charge that flows through the element, which can be expressed as the rate of change of energy per charge. So that's the mathematical notation, the work done across every charge. The work done, the rate of change of energy, which is the work that is done to move one charge, to keep it, to separate them from the unseparated to separated. We're not going to deal with separated and unseparated. Think of it as it's joules per count. Okay? How do we have the notation? Can we have it this way? I already told you about the count, correct? Can I have one student saying, okay, let's do the same thing. Can I have V1? Like this. Do you understand V1? Not really. Okay, can I put plus, negative, and I tell you this is V1? Do you understand it better?
Yes.
Yes. Basically, V1 is actually VA, the voltage at A, minus the voltage at B. In short, I can call it V sub AB. So this V1 is the voltage drop from A to B, which is VA minus VB, or I can call it VAB. How about that? What should I put here? Minus V1. Or I can call it VRACAN. Who cares? So VRACAN is the voltage from B to A. what can we conclude? VAB is minus VBA. Yes. Okay. So VAB equal to minus VBA. Is it clear, ya shabab? So please, over time we will get used to it. But I want you to become familiar with the notation. If you have V sub 2 letters, it means from node A to B. If I have one letter V1, it's a quantity that is usually understood from positive to negative. And if I have positive and negative here, then this is minus V1. You can call it V2, which is minus of V1. Clear? And this slide will summarize it. And V Rakan is what? Is minus V1. Okay? So basically, the positive reference is the head of the arrow. The head, when الهيد حق الارو هذا ولا والله ما أعرف. But we don't use arrows. Okay? وين راس السهم؟ هذا ولا هذا؟ What do you think?
اليسار.
Don't use arrows.
The direction of the voltage is the same as the direction of the current.
No,
إنما positive or negative.
it doesn't matter. I can have V1 and I can have minus I1, different direction. We'll talk about it later. But for now, understand that the voltage is between two nodes. The current is moving across the element. So, the voltage is measured between 2 points and the current is measured through the element. So for example, back to your question, you can have VAB and you can use IBA. That is correct. That is correct. But do we usually do it? No, you have to have your circuit somehow more readable, easier to solve. إذا تورطت في الامتحان الفولتج خلى بوزيتيف نيجاتيف فوق لتحت والكرنت من فوق لتحت. خلاص؟ إذا أنت ما تعرف. If you have a horizontal element, positive على اليمين ونيجاتيف على اليسار والكرنت يدخل مع البوزيتيف. Okay? إذا تورط. We'll talk about it later. Any question about 1.2?
البوزيتيف يمين ولا يسار؟ إذا horizontal.
We will do some example, but خلي اليمين هو البوزيتيف وخلي اليسار هو النيجاتيف وخلي الكرنت يدخل من اليمين لليسار إذا ما أعطاك في الاختبار أي إشارة. واضح يا شباب؟ أوكي. بس أبعد. 5 5. So what is power بالعربي؟ قدرة. What is energy? طاقة. What's the difference between الطاقة والقدرة? Well, if you integrate the power across the time, that's energy. So energy, you need to specify the time frame. For power, it's how capable are you per the unit of time. So in electrical engineering, because we are not physicists, we care more about power. Why we care about power? Because most of our customers, depending on their usage, if they use it for a very long time, then they would consume so much energy. If they consume it across a small amount of time, then they will consume less energy. However, to me as a utility provider, I need to be capable to handle both. So as a metric, we use power to measure the capability of my electric circuit to power such a device. It is not a question of when you have a battery, when you have a lamp. Do you buy a lamp that is 5 watt or you buy a lamp that is 500 joules? Watt. So it tells you this lamp is capable of delivering 5 watts. The illumination of it, the higher the power, the more it illuminates. So in your bedroom, do you want to have a small power or high power?
High power.
Small power. How it's dim light. If in the classroom, do we have high power? Yes, we want the classroom to be. So the question here is about power. Why we use power? To indicate how capable that electric element of delivering energy. Yeah, these lamps, higher intensity than the bedroom. In your office, when you study, do you prefer high power or medium or small? Usually medium. Small you will sleep. Then you will complain about major one. So what is the power? Power is voltage times current. So in any element, if I measure that voltage, and I measure I1, if I multiply V1 times I1, I know the power consumed by resistor. For the battery, if I multiply V1 times I1, I know how much power is being delivered by the battery or absorbed by the resistor. Does the battery produce power or consume power? Produce. Does the resistor consume power or produce? Consume. So for usually when we write our circuit, we write the electric current going away from the source, away of the positive of the source to the positive of the load. So when we do P equal VI, we will not have an issue with the signs because we will solve some examples. So why P equal VI is correct? Because V is volt. What's the unit of volt? Joules per coulomb. What's the unit of amp? Coulomb per second. The coulomb will cancel, we will have joules per second. What's joules per second? Watt. Physics 101, 102. If you did not get a good grade in Physics 101 and 102, good news or bad news? Bad news. I have a theory, by the way. You know my theory? What is my theory? Your GPA usually is larger than or equal your GPA of Physics 101 and Physics 102. It means anything comes in the future will not be worse than Physics 101. Including physics. It's a true theory, right? Ask your friend, who's senior here? Mean is senior. We have one senior. Are you the senior? Is your GPA in Physics 101, 102 higher than your real GPA or lower?
No.
But approximately the same. Approximately. My theory is the GPA حق Physics 101, 102 is either equal to your total GPA or low. Means you cannot do worse than Physics 101. Because those courses are fundamental, ya shabab. Fundamental. You know what's fundamental mean? It means we care about them. That's why it's taken very seriously. Okay? And I always tell the students, which course was the most difficult for me? Math 002. Major 2, I remember I scored 40%, 30%, way below the average. And unfortunately, many of you skip it. Who skipped Math 02? You skipped Math 02? If I become Math chairman, I will not allow skipping Math 02. Because I want you to understand trigonometry. So energy calculation, how to calculate energy? Just integrate over the time you want. I can integrate usually from 0 to maybe 10 seconds, maybe 50 seconds, and then I can calculate the energy. Do we care more about energy or power in electrical engineering? Power. Your electric bill is basically measure your power, multiply by rating, it's a measure of your energy. If you consume so much power, you pay more money. Clear? Now let's go to what we call the passive sign convention. باختصار بالعربي التيار إذا شفته يطلع من إذا التيار يدخل مع السالب for this device معناته عندنا مشكلة. نعيد. إذا التيار يدخل مع الفولتج السالب معناته عندنا مشكلة. لازم نصححها. كيف نصححها؟ ضيف سالب على المعادلة. أعيد بالعربي قبل ما ندخل. إذا التيار يدخل في الجهاز مع السالب معناته عندنا مشكلة. كيف نصحح هذه المشكلة؟ نضيف إشارة سالبة على جميع القوانين عشان نصحح هذا الخطأ. نعيد. إذا التيار يدخل على الجهاز من الإشارة السالبة معناته عندنا مشكلة. What is this problem?
مو المفروض هو اصلا يدخل بالسالب، يعني هو يطلع من
عندك من كذا احنا بنسهل الامور. اذا التيار يدخل من السالب معناته اوقف تفكير. اقول اي قانون اكتبه لازم احط فوقه سالب عشان اصحح هذا الخطا. واضح؟ This is what we call the passive sign configuration. I will explain it now. And forgive me, I will read from the board a little bit. If the current moves from positive polarity through the element toward the negative polarity, then the element absorbs energy it gains like the resistor. إذا التيار يدخل مع الموجب أمور طيبة. This device consumes power. This is business as usual. لأن احنا متعودين التيار يدخل من وين؟ مع الموجب. If the current enters through negative terminal for this element, here we have if the current, which is what I called you before, current هو الهولز, positive charge, moves from a negative toward the positive, في عندنا شيء لازم يتصحح. So the energy we have lost, it means negative energy. So it means it supplies energy. Can you think of an element where we have to have the current enters through the negative? رسمتها اليوم. أنا لما رسمت الباتري ما قلت لكم ارسموها كذا؟ معناتها إيش؟ It goes to whatever system, then it goes back and enters through negative. معناته إن عندي مشكلة في هذا. I need to fix it. It means it supplies energy. We're losing energy. It's a negative energy provided by the battery. But if it goes through resistor, it enters مع الموجب, then it absorbs energy. Now, can I have an EE236, a resistor where the current enters from the negative? Yes. Sometimes if you draw your circuit, the examiner already would label the current enters through negative. Can you say no to the examiner? Can you go change the direction in the exam? No, because he's asking you for that particular current. لا أشوف أحد في الاختبار يروح يشطب على الاتجاه اللي حطه الدكتور ويقعد يفترض التيار من عنده. Basically, you're getting the negative of that current. So what is the passive reference configuration? Here or there? Second. It cares about the second. Why? Because it's an unusual. Basically, if energy is absorbed, positive current يدخل مع الموجب, passive reference configuration is fine. If the energy enters from a negative, then I have to, it's not following the configuration like this. It's not following. كيف نصححها؟ نشطب عليها؟ لا، في المعادلات نحط سالب. بعدين نوريكم. In the equation we put negative. This is very fundamental. Yes.
So رسمتك صح ولا لكن
هذه برضه صح. لكن الإكس هذا معناته it does not follow the passive reference configuration. It is a true, but it does not. من وين يدخل التيار؟ هذا يدخل مع الموجب.
لا مع السالب.
يدخل مع السالب ويطلع من الموجب. It is correct, but it doesn't follow the standard passive reference configuration. How to fix it? In the equations later, we add a negative sign to fix it. Let's look at this example. Which one of A or B or C does not follow passive sign configuration? يدخل من وين؟ يدخل من وين؟ يدخل من وين؟ أي واحد منهم؟ B. It means B does not follow the passive sign configuration. That's element number 1. 2. Consider the circuit elements, calculate the power for each element. So, so which one follows the passive sign configuration? A and C. So let's solve it. What is the formula for power? V and I. So what is the power here?
24.
24. What's the power here?
20.
خلها زي ما هي minus 36. Do not change it. For the element that where the current enters from a negative, هنا عكسها. قلب كل شيء. كان أخذ A قلبها. For the element B, it's P equal V times I, and then we multiply by an additional negative sign. So it's minus VB times IB. So this negative نحطها غصب to fix the passive reference configuration. Again, so what's the power here? It's minus 12. So it means this is absorb, this is supply, this is supply. Clear? اللي ما فاهم يرفع يده please. I want to see some hands. ما فاهم.
ايوه.
طيب.
شلون في اذا كانت باسف ما نضرب سالب.
خليك من باسف. إذا ما كانت باسف ما نقول. أول شيء before A, the current enters from a positive ولا negative؟
A.
إيه. التيار يدخل element A من الجهة الموجبة ولا الجهة السالبة؟
من الموجبة.
من الموجب. أوكي. B, التيار يدخل element B من وين؟
من السالب.
من السالب. C,
يدخل من الموجبة.
يدخل موجب. معناته أي واحدة منها فيها إشكال.
B.
خلها بعدين. نجي للسؤال. Calculate the power for each element. What's the power?
VI.
VI. Go to A. What is VI?
12
24. Go to C. What is V? C times IC?
minus 36.
Minus 36. Because this is positive, the final answer is positive, it absorbs. Because this is a negative answer, it supplies. We solved A and C. Let's go to B. Does it have a headache? Yes or no?
Yes.
Yes. Why it has a headache? Because the current enters from the negative. It means in the original formula, P equal VI, I need to fix it. How to fix it? Add negative. And that's why we have a negative. It's negative 12 times 1, it's minus 12. Final answer is 12. It means it supplies. Clear? Okay, please. That's very important. When you solve big circuits, we will ask you questions about it. Okay?
دكتور
Yes, please.
البي وسي هي اللي فيها سبلاي صح؟
No?
ولا بس بي؟
The only one, B and C supply. Sorry, you said B and C?
Yeah.
Yeah, B and C, because the final answer
فاينل انسر
is negative, it supply. The final answer is positive, it consumes, absorb. واضح؟ I will ask for your first name. What's your first name? 1, 2, 3. Yes. Hamad. Is this good or bad? Trust yourself.
Good.
Good. So what's the power?
نضرب الواتر في الكتاب.
Which is 12 times 2, 24 times E minus T. Easy. Is it a problem? Now note that because the current is a function of time, the power will be also a function of time. Is the voltage a function of time? No. Is the current a function of time?
Yes.
Yes. So the power has to be a function of time, which is 24 E minus T. Is this absorbed or supplied? Can this be a positive number or a negative number, or it depends?
Always positive.
Always positive. Because it's always positive, it absorbs. Okay? Now the other question is calculate the energy from 0 to infinity. I don't know how to do math. Math is hard. But I think the final answer looks like 24 joules. And note that the energy is also positive. This, go back to building 5. Okay? Do you know how to do this integral? I think it's what? The integral of E minus T is minus E minus T, and then you will, this is the negative here, so it's minus 24. And then you take the limits, so minus will be positive. Math is hard. Let's go to this exercise. Always read the question. But before you read the question, let's say, is it good news or bad news? Good news or bad? Is it passive reference configuration compliant or not? هذه compliant ولا لا?
Yes.
Yes. هذه compliant ولا لا? How to fix it?
Multiply by minus.
You have to add a negative sign before the equation. Read the question. Compute the power as a function of time for each of the elements shown in the figure. Then find the energy between 0 and 10. And then tell if it's supplied or absorbed. So what is the power for this element? 20T squared. 20T squared. What's the energy? 20 over 3T cubed. And then you take the limit from 10 to 0. And then you should have the answer of 6667. Do I need to solve the integral? For the sake of time, no. But if you cannot do it, let me know. And then, is this positive or negative? 22 squared. It's always positive. It means it absorbs. Okay? How about the other element? What's the power? I'm going to solve the other element. What's the power? V times I? Wrong.
Minus.
Power is minus V times I. What is V?
20 minus.
20 minus 2t. What is I? 10. So what is the power? Minus 200 plus 20t. What is the energy? Integration from 0 to 10 of the power. What's the integral of that? Minus 200t plus 10t squared across the limit. That's how I do across the limit. Right? From 0 to 10. Which is what? Minus 2000. I think this is a t squared. Plus 110 times 100. Minus 0. Minus 2000 plus 1000 is minus 1000 joules. Is this absorbed or supplied? Supplied. Also, you can note from the power minus 200 plus 20t, this will not be positive until a certain amount of time, which is what, 100 seconds, correct? Or 10 after 10 seconds. After 10 seconds, the power will be positive. That's why the energy is absorbed. So please solve these exercises. They are very useful and they are solved here for you. For AC voltage and current, check the sign of energy to decide if the element absorbed or supplied. I think that's enough. And I'll let you go outside early. There is no point to start KCL today. Okay? Do you have any question? Yes. So AC means alternating current. So is the voltage here DC or AC? Is the current AC or DC? AC means changes with time. DC means constant with time. Is that current constant with time? No. 2T. So it's AC. Is this voltage AC?
AC.
AC. Is this current DC?
DC.
Is this current AC? Voltage AC?
Yes.
It's AC. So AC, AC, DC, AC. Power is AC, power is AC, because if you multiply AC with DC, it becomes
Yes.
AC.
دكتور هذه تبدا بس السلايد اللي قبلها. اي دكتور هذه الرسمه كيف عرفت ان مسألة قلت ان امورها تمام؟
امورها تمام because the current enters from the positive.
بس بتطلع من
انا علي تدخل، ما علي بتطلع، ما بتنتر. I never said leave.
الرسم اللي في السبوره طالع من الموجب.
No, this current enters the negative, leaves the positive.
هذه كويسه يعني.
هذه you have to add a negative في الباور. هذه you don't have to add a negative for it.
لانها بتدخل من السالب لكن هذه تدخل من الموجب.
Yes.
فهي لازم تدخل من الموجب.
في أي circuit you will have some of those elements where the current enters from a negative. إذا تيار يدخل من السالب معناته الليل طويل. You have to add a negative. And this would cascade when we do node voltage analysis, when we do current analysis, it would matter. For now, you always have to keep in mind, if the current enters in negative, I have to add a negative.
دكتور ايش فكره بس ليش ندخل النيجاتيف؟
لأن المعادلات حقت الكهرباء كتبت بناء على الكونفيجريشن ان التيار يدخل مع الموجب والفولتج from high to low. فthis to fix بدل ما تعكس التيار كل مرة، بدل ما تعكس التيار خلي التيار زي ما هو وتحط سالب. هذا الفكرة. Clear? So when okay, quiz 1 will be Wednesday. Not this Wednesday, the following Wednesday. Okay? And it will cover until the material of the previous lecture. Can talk about it. Study. Okay? I will stop the recording because I want to talk to you.